Hello and welcome back to Stats Coach. Today we're going to do an introduction to the Poisson distribution, when to use it, and how to use it in Excel. So Poisson is used when there are discrete occurrences over a continuous period. So that could be calls to a call center or the number of potholes in a road. So in these two examples, the discrete number of occurrences would be the actual number of calls in the call center and the number of potholes. And the continuous period would be, for the call center, it would be time, so number of calls in an hour, let's say, or the number of potholes in a mile of road. So the continuous period would be the mile of road. The equation for Poisson is mu to the x, e to the negative mu over x factorial. And mu is the average number of instances of those discrete occurrences that you would expect to see. And the x is the number that you sort of are searching for or want to see. So we'll see that in these two practice problems. So the first practice problem, on average, there are 2 potholes per mile. In the next mile, what is the probability that there will be exactly 3 potholes? So again, we have to find the mu and the x. So mu, again, is the average. So if there's an average of 2 potholes per mile, then mu would be 2. And if we're searching for what is the probability that there will be exactly 3 potholes, then our x is equal to 3. Notice both of these are per mile, so 2 potholes per mile, 3 potholes per mile. That's important. We'll cover that in a later video about what to do when they are not in the same units. But now, using the equation, we can simply go 2 to the 3 e to the negative 2 over 3 factorial. So that is equal to 8 times e to the negative 2 over 6. So using our calculator real quick, we can do 8 and then times, and on this calculator we do second ln to get the e to the power, and then negative 2 divided by 6. So here we have 0.1804, which is about 18%. So now we know that for this problem, so that's about 18%. So for this problem, if you average 2 potholes per mile, the probability that there are exactly 3 potholes is about 18%. Let's do something a little bit more complicated. On average, an individual makes 5 typing errors per minute. What is the probability that the individual makes between 3 and 5 typing errors per minute? So for this problem, when we have a range, we actually are going to do Poisson, use the equation 3 different times and add them together. So mu is always going to be 5, because the average is always 5. But if we want a range between 3 and 5, then we're going to have to calculate 1 time for 3, 1 time for 4, and 1 time for 5. So I'm just writing x sub 1, x sub 2, and x sub 3 for the different occurrences. So let's set up our 3 equations. So we have 5 to the 3 times e to the negative 5 over 3 factorial plus 5 to the 4 times e to the negative 5 over 4 factorial plus 5 to the 5 e to the negative 5 over 5 factorial. So again, we're just plugging in x1, x2, x3 into these 3 equations. Now let's simplify them a little bit further. So 5 to the 3 is 125 times e to the negative 5 over 3 factorial, which is 6. 5 to the 4 is 625 times e to the negative 5 over 4 factorial, which is just 4 times 3 times 2, which is 24, plus 5 to the 5, which is 3,125 times e to the negative 5 over 5 factorial, which is 5 times 4 times 3 times 2, right? So 120. All right, so now let's take the last step and simplify these. So 125 times e to the negative 5 divided by 6. So we have about, we'll do 4 decimal places, so 14.1404. And then 625 times e to the negative 5 divided by 24 is 0.1755. And 3125 times e to the negative 5 divided by 120 is also 0.1755. Okay, so now let's sum all of these together. So 0.1404 plus 0.1755 plus 0.1755. And we get a total probability of about 50%, so 0.4914. So essentially, if you're averaging if you're averaging 5 typing errors per minute, the probability that you make between 3 and 5 typing errors per minute is 49.14. So the final part here is how we use Poisson in Excel. So we can use the equation equals Poisson.dist, and you plug in x, the mean, and whether or not it is cumulative, and then you can use Poisson again. So in Excel. So x here is the number of occurrences that you're seeking. So for instance, in the last problem, x would be 3, 4, and 5 respectively. Okay, so now I have this pulled up in Excel, and we can see that if we do equals Poisson.dist, it asks for x, the mean, and cumulative. So again, x is the number of occurrences that you are seeking. The mean is the average number of occurrences over that continuous period. And then cumulative is whether or not you want to cumulate the probability from the left tail. So let's do the first problem that we did previously, which was if the average number of potholes in a mile is 2, what is the probability that there are exactly 3 potholes? So the average is what actually comes second. So we're seeking 3 potholes in a mile road that averages 2. And then here it's cumulative, it's not cumulative rather. So we do, for cumulative, we put false, because we're seeking exactly 3 potholes. So here we're getting the same answer that we got previously of 0.1804, or about 18%. But for the probability within a range, we actually are going to use cumulative probability, because if you're searching for something that's between, let's just write out this. If you're searching for between, so we're talking about typing errors, and if the average is 5, and we're searching for between 3 and 5. Well, cumulative will only tell you whether it's 5 or less, 4 or less, 3 or less, etc. But if we do 5 or less, and then we subtract out the probability that it is 2 or less, we'll be left with between 3 and 5. So let's find the probability that there are 5 or less errors, and then find the probability that there are 2 or less errors. And if we subtract these, we will get the probability that there are between 3 and 5 errors. So for 5 or less errors, we could do Poisson, and we're for seeking 5 errors, and it averages 5 errors. This is for the typing problem again. Here we're doing true for cumulative. Now we know the probability that you have 5 errors or less is 0.6159. The probability that you have 2 errors or less is going to be 2 for x, 5 for the mean still, and true again for cumulative. And now to find between 3 and 5, we could just subtract the 2 or less from the 5 or less. And again, we're getting the same answer of 0.4913. I think previously we got 0.4914, but that's within a 10,000th, so it's pretty accurate. So now we know how to use Excel as well as a handwritten formula to use the Poisson formula to solve for issues where we have a discrete number of occurrences within a continuous period. Thank you so much. I hope this video was helpful. Comment down below if it was, and best of luck with your statistics endeavors.